Okay, welcome to the second video of 9.4. Last video you looked at the sine function and the graph of it. Here we're going to look at the graph of the cosine function. Now these functions, you're going to see in a second, when you look at the graph, they looked almost identical, but they are actually different graphs. They're just shifted from each other. So it's really important to understand the characteristics of each so that you can, when you're looking at a graph, you can identify which one you're looking at. So here we've got our function, 1/2 cosine of 2 pi x. So just like we did last problem, we're going to look at the amplitude and period and a couple other key points about this graph, key features. Then we're going to describe it as a transformation of the parent function. So we already know how to take amplitude and period. We've got right here, we've got our formulas. Amplitude equals the absolute value of A, and period is 2 pi over B. Now, what I want you to notice, look at the cosine here. Now, at first glance, you may think you're looking at the exact same wave, but there's a difference here I want to point out to you. When you look at the sine function right here, remember our sine function, our period starts at 0, 0, and when we start, our wave is right at its midpoint. If you think of the x-axis as like an imaginary line, that's cutting this wave in half. Okay, so it starts, sine starts at the midpoint, goes up, back down to the midpoint, below, and back up. Makes like this S curve right here. Okay, that's our sine function. If we look at cosine, cosine is the exact same wave, but it's just shifted a little bit. If you look at the start of our period, so our period starts at 0 and goes to 2 pi, that's the same, the period length is the same. Look what happens though. Our cosine function actually starts at its maximum value. It starts at the peak of this little hill. So our cosine function starts at the top, comes down at the midpoint of the period. It's at the bottom of this curve, and then it comes back up to the top, and after one complete cycle through, we're back up where we started. So if you look at this, it's kind of like a U or a cursive V that you're making. So that's the way I like to think about it. The sine functions are like a S, and the cosine functions are like a U or a V. Okay, so you're starting at the top, coming down to the bottom, and coming back up to the top. All right, now in terms of your intervals for your x-intercepts, for cosine, our x-intercepts occur every pi over 2. So they start at pi over 2, and then when you add pi, they go forth from there. So pi over 2, 3 pi over 2, 5 pi over 2. So at pi over 2, and then at intervals of every pi, you have intercepts. So again, if you look back, here's the start of our period. The first intercept is at pi over 2. Then it comes up. The next intercept is at 3 pi over 2. Comes up. The next intercept is at 5 pi over 2, and so forth. So they keep crossing the x-axis at intervals of pi, every pi, starting at pi over 2. So let's go back to our problem. So we want to identify the amplitude and period of this function. Well, remember, this looks just like our generic form right here. Y equals A times the cosine B of x. So we know we can get our amplitude and period by pulling these values out, A and B. So let's look. So here, if we look at our function, we know that A equals 1/2. And in this case, we get B equals, look at the value that we're multiplying by x. We get B equals 2 pi. So that's the first step to identify your amplitude and period. You have to look at what your A and B values are. So here we've got A equals 1/2, B equals 2 pi. Okay, let's go ahead and click through. We see that our amplitude is just 1/2 because it's the absolute value of A. And our period is 2 pi over B. In this case, B is 2 pi, so our period is just 1. Now what that means, remember, period is the horizontal distance that it takes our wave to do one complete cycle. So in our parent function, our period is 2 pi. Let's look at what happens when we look at 1/2 cosine pi over 2. Look what just happened here. First of all, the height of our wave shrunk. So our amplitude is 1/2. Our amplitude is the distance from the center to the top, so 1/2. And our period is the distance it takes to do one wave. So if we start here, here's our starting point. We come down, we hit our minimum point at x equals 1/2. We come back up, and at x equals 1, we've done one complete cycle. So this right here is an example. We just did a horizontal shrink. Imagine taking this whole wave and compressing it together. That's what a shrink looks like. So let's look at some other key points. Our x-intercepts are at, if you look back at our graph, it's at 1/4 of the way through the period and 3/4 of the way through the period. So the way you get your x-intercepts is by just taking 1/4 times your period and 3/4 times your period. So our x-intercepts are at 1/4 and 3/4. Our maximum, again, our maximum is at our starting point, so 0, and the end of our period. If you go back here, our maximum is at the start of our cycle and the end of our cycle. So at x equals 0 and x equals 1. Our minimum is going to be halfway through, so our minimum is going to be at 1/2 and -1/2. So here's a little sketch of ours right here. Now we just said we've got again, the transformations are a vertical shrink, because if you look back here, vertically we shrunk this down. It had a height of, or an amplitude of 1 down to an amplitude of 1/2. So this 1/2 right here makes it a vertical shrink. And remember, our horizontal shrink, this is our b value. 2 pi is our b value. So our horizontal shrink is 1 over b. So this was a horizontal shrink by a factor of 1 over 2 pi. Okay? So again, a lot of stuff in here. You should go back and rewatch it just to make sure you have everything. I would recommend trying to trace out one of these waves as well. What I want you guys to do is look at this function here. We've got the 3 times the cosine of pi x. What I want you to do is I want you to identify the amplitude, the period, the maximum value, and the minimum value. And in this one, I also want you to tell me what the transformations are from this to our parent function. So what are the transformations from 3 cosine pi of x to cosine of x? So you're writing down 5 things here: the amplitude, the period, the maximum, the minimum, and all of the transformations from g to the parent function f. Go ahead and write those in now.